The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Question 7 says, if the radius of the Earth were twice its current value, but its mass were the same, then what would be the acceleration of gravity g at the Earth's surface? Okay. So this is just asking you to solve for the new acceleration if we change some parameters of the Earth. So we're going to say that the radius is going to be twice the current value. So I'm going to designate the new radius by r prime and say that's going to be equal to 2 times the original radius r. And we can say that because the mass is said to be the same, we know that m prime is going to be equal to m. New mass equals the old mass. Okay? So the way to solve for the acceleration, actually an interesting little concept, is we know that force is equal to our mass times our acceleration, which is also equal to g times the mass of the Earth times the mass of our object over the radius of the Earth squared. Okay? So looking at just this part of the equation, if we're looking at the same object, that's going to be our little m, we can solve for the acceleration of any planet by g, or gravitational constant, mass of the planet divided by the radius squared. That will give you the acceleration. If you plug in the mass of the Earth and the radius of the Earth squared and gravitational constant, you will get the gravitational constant g of 9.8. So we know now that a is equal to g m over r squared. Now this is going to be equal to g, basically, if we're using the mass of the Earth and the radius of the Earth. Okay? What we're concerned about is the acceleration if we change those things, which would be g m prime over r prime. So, familiar with proportions, this is how you can do the problem. You can say that plug in, well, m prime is just, we're just going to plug in m, and r prime is going to be 2r squared. Now, don't forget, remember that 2 is going to be squared there as well as the r. So we're going to end up saying a is going to be equal to g m over 4r squared. So, just with a little bit of manipulation, we can rewrite this equation as a is going to be equal to 1/4 g times the original mass of the Earth times the original radius of the Earth squared. And we know that that's equal to g. Alright? So, what we can do is just plug in a is equal to 1/4 of g, or 1/4 of 9.8. Which I don't even believe. Yes, they do actually ask you for the numbers. So, once again, in this problem, they're using 10 for the gravitational constant. So, the actual correct answer is going to be 2.5 meters per second squared. Now, if you plug in 9.8, you're going to get something really, really close. So, hopefully, when you look at these answers, which are all actually, the nearest answer is 5. So, when you get like 2.4 something, you hopefully recognize the fact that, well, that 2.5 is going to be the right answer. Now, if you, I can't remember exactly what they give you on your formula sheets. If you have the math, or the mass and the radius of the Earth on your formula sheet, or you, for some reason, happen to know them off the top of your head, by all means, just plug them in. Excuse me, I definitely forgot to put that squared term there. Sorry about that. But you can absolutely plug in the original mass of the Earth and twice the radius of the Earth and solve for a. That would work perfectly fine. For those of you who don't have it, or want to do it a slightly less numerical way, this is definitely going to be your quickest way of solving for the acceleration, just 1/4 of gravity that we have.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.